Hi everyone, today we're going to be talking a bit about set notation. This is just so that we can be really clear when we're describing the range and domain of a function, and we can be really clear what numbers we are and aren't including in our set. Now a set is just a collection of any objects or elements. So in our case it's going to be numbers, and these are just some of the symbols that you do need to remember the use for. Now, some of the really common ones you're going to be using are those squiggly brackets for the set, as well as things like union, intersection, and an element of. We very rarely use things like not an element of a set because we're describing the numbers that we are using. So they're just some really important symbols that you do need to remember. Now, when it comes to describing sets, we also have a bunch of different symbols that we like to use, just so that we can shortcut it. Instead of saying from 0 to infinity, there are shorter ways that we can say that. Now, some of the symbols that are really important to remember are things like this R for real numbers, and this Q for rational numbers. Now, it's very rarely that you're going to describe a set for graphs that only include rational numbers, because you're usually including the whole spectrum of numbers, such as your positive real numbers and your negative real numbers. Now, if we want to specify positive real numbers, we're still going to use our R, but we're going to put a plus there. So the plus does just say, hey, we're using the positive ones. Same for negative, we're still going to use our R, but it's going to be a minus. And then sometimes we're going to want to, for things like square root, say, hey, we're going to use positive real numbers, but we are going to include the number 0 in there because I can take the square root of 0. So to do that, we still do our R plus. And then we say, well, we're also going to include 0. So I can have positive real numbers or I can have the number 0. Same thing for negatives. You can write your R negative and then just say, or we can have the number 0 as well. Now, irrational numbers, once again, you're very rarely going to have a set of numbers that just includes rational numbers, but the letter for that is P. And then natural numbers, we've got the letter N. The last one, which hopefully you remember from our circular functions work, is integers. We use the letter Z for that with the special little line there, because there are times when you just want to use whole numbers. And we can once again say we only want positive integers or negative integers. So those are just some symbols that are really important to remember. Now, when we describe the set of numbers that we are using, we like to use something called intervals. And an interval is just a restricted domain with endpoints. Now, sometimes we want to use those endpoints and sometimes we do not. But the thing is that a lot of the time we do like to restrict what numbers we are using. We don't always want to use every number under the sun, especially when you're working with application questions where we're looking at real life scenarios. And positive numbers are the more commonly used number. Now, when it comes to restricting a domain with endpoints, one of the things to remember is that we use an open and closed circle. So if we have a closed circle, that's an included value. And if we use an open circle, that value is not included. Okay, so that's just something to really hone in on. We do the same thing for a number line. If, let's say, we wanted to denote an interval here, and I'm saying, oh, I want to use the numbers between A and B, but I don't want to include A and I want to include B. I'm going to make sure I'm really careful with which circles I use, and then I'm going to connect the two up. Now, this is essentially saying, hey, I'm using those numbers between A and B, but I don't want A, but I do want B. And if we wanted to use set notation, which is our more kind of formal way of writing this down, we're going to use our squiggly brackets to say, hey, I'm writing a set here. And then I'm going to say, well, X is a part of what I'm writing after this, okay? Then I'm going to say, well, A was less than X because we were not including it. But X is less than or equal to B because we are including it. So what this is saying is I've got a set of X values such that X is less than A, but it is, greater than A, but it's less than or equal to B. Okay, so it's greater than A, and it's also less than or equal to B. Okay, so that's what that little set there is saying. Okay, if instead I wanted to use interval notation, which is more common, we just like to use our open and closed brackets. So in this case, I'm going to say, well, x is an element of what I've got written here, and it's a part of the numbers a to b, but we're not including a because of that round bracket, but we are including b because of that closed bracket. Okay, so it's really important what notation it is that you are using. Now, if we were to do these all on a number line as well, for our set notation, I can say, well, I've got some numbers a to b, and x is in between them, but and is included. Sorry, and we would use our little squiggly brackets here. Okay, whereas our interval notation, I would just use my square brackets for both of these. Okay, in doing that, we'd have our coloured in circles connecting the two up. I could do similar and say, well, x is not equal to a, but it is equal to b. Well, then I'd have an open circle for a and a closed for b. And then when I write that out, I would have my open bracket for a and my closed bracket for b. Okay, I can also not include the both of them. That is also perfectly fine. And in doing that, I just need to make sure they both have an open bracket and that they both have open circles. Okay, so you can also not include those endpoints, and there are situations where that does occur. Now, we can also have an unbound interval where we say, okay, well, x is greater than this number or it's less than this number, but I don't have a defined endpoint on the other end. And in this case, we use the symbol for infinity to denote that. So, for example, I'm going to say, well, x is a part of this set where it's less than a, okay? In doing that, I'm going to say, well, it's all the numbers that come before a, so all the way to negative infinity and up to a. And I'll still use my open circle, but have an arrow saying, well, I don't have a defined endpoint for this one, okay? Same thing if I was to say, well, actually, x is greater than or equal to a. Well, we'd say a is included in this set, and we go all the way to infinity. So I'd have a closed circle and then going all the way to infinity. We can also have a split interval where there are numbers that we don't want to include. So in this case, I'm going to say, well, x is less than a, and I'm going to use that union that I showed you before to say, well, actually, x can also be greater than or equal to b. And we saw that in our quadratic functions and quadratic inequalities where we had certain sections that just were not included, okay? If I was to write this using set notation, I'm going to use my negative infinity to a and then union that with a b through to infinity. And that should be a closed bracket for the b and never closed brackets for infinity because we haven't defined that endpoint. And infinity is not a value, it's more just a concept. If we were to, let's say, exclude a value, I could say, well, I want every number except for a, right? So I'm going to include every single real number I can think of, but I'm not including a, okay? In this case, the set notation and the interval notation are quite similar, but I'm going to do an open circle where a is, and then include every value on both sides. If we were, let's say, including a value, and your most common version of this is your real positive numbers and also including 0, then I would say, well, x is a part of all real positive numbers, including 0, okay? And then for set notation, we would just say, well, x is greater than or equal to 0, right? So if I was to draw this out and say this is 0, this is going negative infinity and positive infinity, well then it's every number that's 0 and above. Okay, so set notation just makes it really clear as to what's included and what's not. Now, when it comes to infinity, there's a couple of things to note. All right, we always use brackets and we always use the round brackets. Okay, and the reason for that is because infinity is not an actual value. It's more of a concept that we're reaching towards, okay? So we can't close infinity in, so we have to use an open bracket. So in this case, we'd have things like negative infinity to a, well, that would be a closed bracket going to the left. Negative infinity to infinity, it would just be an arrow going both ways. Let's say we had negative infinity to b, that would be an arrow that goes towards an open circle. When it comes to using infinity, we should always be in numerical order. So you can't say from negative infinity, or sorry, from b to negative infinity. It has to be from negative infinity onwards. So negative infinity to b would be correct, and that is not the same as saying I'm going from b to negative infinity, okay, because we're starting small and going bigger. Now, if you would like, feel free to pause the video here and have a go at these, but I'll also go through them. For this one, 3 is not included, but 5 is. So I've got open circle and closed circle and connecting the 2. Now, negative 3 to infinity, negative 3 is not included, and we're going to go all the way to infinity. For this one here, I want all numbers included except for negative 2. Now, even though it's a closed bracket here, I don't want to include it. So I'm going to open that circle up. And then same for this one here. Originally, it wasn't part of that set, but now I'm saying I do actually want 3 to be a part of this set, and we're going to work from both sides. We don't want what's in between them. For this one here, it's a little bit trickier because you have to find the intersection points between them. So negative 4 to 3 would go from here to here, with that being a coloured in circle. For the second part, which was negative 2 to 5, we would have an open circle here and a closed circle here. Okay, now this part is still being included, this section, this 3 here would still be included because it was included in the negative 2 to 5, whereas the negative 2 wasn't included here originally. So our final answer for this one would be going from negative 2 not being included to 3 being included. Okay, so this is the same as saying I'm going from negative 2 to 3. Okay. This one here, we've excluded some numbers here, so that's something to really keep in mind. We're working from negative infinity to negative 1 included, and then we're also going from 3 to infinity. All right, the other way that we can write this one out is to say I've included all numbers except for not negative 1. All right, so that would be a round bracket because it is included in the set. But then we're going to include 3 here because it's not included in the original set. Okay, so we're saying all numbers from there to there. This one here, we've closed the interval on both sides. So this one's going from negative 4 to 0, and it's also going from 2 to 5 not included. Okay. Now, last little bit for notation is we use it to denote domain and range. Right, that's the main reason we use this sort of notation. So feel free to pause the video here to give this one a go. If I'm looking at the domain, I'm looking at my x values. We very clearly go from negative 2 to 7. Okay, so that one's usually one of the easier ones to see. The range, you have to look vertically, right? We have to go up and down. So I'm going to go, okay, well, this value here is negative 5. That's my lowest. And even though this value here is not included, it is on this side here. So we're going to have a, closed brackets for both of these values, with the highest y value being about 15 over 2 is what I'm seeing. Now, same thing for this circular function here. We can see x goes from 0 to 2 pi. And then y is our lowest and highest points going from negative 2 to 4. So that's what we most commonly use set notation for.